Good afternoon. I'm Marco De Biasio from the product team of SCIA, and today in the webinar we are going to talk about construction stages with SCIA engineers. Before to start, just some word about the use of GoToWebinar. You are muted, then it means that you cannot interact with me with the voice. But of course, you can ask a question using the specific panel questions of the tool GoToWebinar. I will reply to some of these questions at the end of the webinar, and the questions that are still remaining, I will reply them via email. The webinar is of course recorded, then it will be available in some day in YouTube in our SCIA chain. Then let's go to see the subject of today. Firstly, I want to talk with you about the construction stages in SCIA Engineer, the current situation, the past solution, and what we can expect for the future version of SCIA. Then the main subject of the webinar is to show you how it is possible to do linear construction stages just by using model modifier. Then I will build a model from scratch in which I will show you how to stage it. Okay, then let's start and let's go to see which is the situation with construction stages in SCIA Engineer. As you know, currently SCIA Engineer is offered in two versions, the 64-bit version and the 32-bit version. The two versions are fully compatible, as you know. Concerning construction stages, they are currently available exclusively for the version 32 bits. In this one, you can do linear construction stages, non-linear construction stages, as well as 2D time-dependent analysis. In the current 64-bit version, there is not at all construction stages. The fact that there is not, it doesn't mean that it will be forever like this. In fact, is it planned to implement the construction stage functionality also in this 64-bit version, because the aim is to dismiss the 32-bit version and have one sole version fully available with all the functionalities. The implementation of the construction stages in a 64-bit version it's already planned. We will have linear construction stages, non-linear construction stages, as well as 2D and 3D time-dependent analysis. The aim is not just to migrate the current functionality offered by the 32-bit version and to put them in the 64, but is to do also something better, something that is more user-friendly and better respond to the request of the user. And concerning this, the construction stages in 64 bits are currently under definition. Then I take advantage of this webinar to ask every one of you that is interested in this functionality and has some proposition, some request about, please write it into the chat or just let into the chat your email address saying that you want to be contacted by me, and we can organize a short Teams meeting so to discuss about what are the functionality in the construction stage that you really would like to have in the next version, how to do in a better way with respect to the current solution, where the current solution lacks. So with the aim to really build a construction stage module that really meet your expectation. So, said this, let's go to see how to build a construction stages model in SCIA Engineer just with model modifier. Model modifier, what is this? It's a functionality of SCIA Engineer that you can enable in the functionality setting of the project data menu. And what it allows to do this functionality? In fact, it allows to specify for a different kind of element like supports and 1D and 2D elements, their absence. Then you can say that some support or some element is absent in a particular configuration. you can do a similar things, saying that not that the element is absent, but that there is some stiffness modification. And the particularity of model modifiers, what make them interesting in order to create a staged model, is the fact that once the modifiers are created, they are associated to a group. You can create one or more groups of model modifiers, and these model modifier, they can be associated to load cases. Then you can have a load cases that is associated to a model modifiers group, another load case that is associated to another modification group, or you can associate more load case to the same group. But manipulating with this entity will allow you to create, in fact, several load cases in which, in fact, the configuration of your model is different because there will be elements that are present in some load cases and absent in another. Just I make you remark, be careful, the functionality is model modifiers and not property modifiers. These two functionality are similar in what they do, and they both allow to specify some absences, some stiffness modification, mass modification, and so on. But the difference is that only model modifiers, they can be associated to load cases. The property modifier, they act for all load cases. Then said this, let's go to see the example that I will go to build in direct in SCIA Engineer. The example that I want to build live in SCIA to show you the application of model modifier to construction stage is this one. We want to build a model of a simple structure representing a bridge, for instance, and then we need to have several stages to do this. The first stage represented at the screen, it's the one in which we build the columns of the bridge. Then you see I put it in green. It means that in this stage one then we have only the columns with their support. Successively, for the stage 2, we add a beam between the two columns. You see, we start to build the model. You can see a part in gray that it's a part that there is not yet in the model because we didn't arrive yet to that stage. In stage 3, I will add other beams, so to build the whole horizontal part of the bridge, and I will add two supports at the extremity. In stage 4, I will remove the columns. Then you see that in red, it means that this element will be removed, then will be absent in this stage. And I will add two temporary support and the position indicated in green in the image. And successively, in the last phase, I will remove this temporary support in this position here in red, and I apply an exploitation load on the bridge. So let's move to SCIA to see how to build this simple staged model. I open SCIA Engineer and I create a new project, then new. For the example, I will use material concrete, and for the functionality, for simplicity, I will disable all, but I will take care to activate the model modifiers. Okay, the graphical interface is loading. Okay, perfect. Then let's create our model. If I come back a moment on the PowerPoint, what we have to create, in fact, for all these stages, we have to create the full model, then with all the elements, disregarding if some element is absent in a stage and present in another. The first step is to put all the elements into the model. Then let's go back. I will start creating the cross sections. Then let's say for the horizontal part of the bridge, I will take this cross section shape for simplicity. Let's say 4 meter and a half of width and 1 meter and a half of height. Let's put 200 millimeters. 200 millimeters. It's just an example. Okay. And for the temporary columns, I will take a circular section. For instance, diameter, let's say 600 millimeter. Okay. Close. Let's now create the horizontal elements. I will use the beam command. Then the cross section is this one. The length of the beam, let's say 8 meter. Okay. And now I will say input the first and the second and the third element like this. Okay. And the temporary columns, then the circle section, insertion point I will put top 8, let's say 5 meters. Okay. And I will put here and here. So now we have all the elements of the structure. Like this. What we have still to input are the support. Then again, if we come back to the PowerPoint, we have support at the extremity, are the final one, but also we have temporary support at this position here. Okay, go back to SCIA and input this, and I'll put support in nodes at the extremity, let's say hinged, here and here. At least for one of them I will change, and I will say I will block also the rotation on his on the beam axis to prevent instabilities when I will have only the horizontal part. We have to input other two support in the middle, at mid-span of these two beams here and there. For this, what I can do, I can input an internal node on this at midpoint and another internal node on this element, again at the midpoint. And again, I can input an hinged support also here. For instance, this support, I can also remove the hinged, in fact, and lock only the vertical reaction. It's for this that we put, just to sustain vertically the structure temporarily. Okay, the structure is complete with all the elements that we want to input. We have the columns, we have the beams, and we have the supports. What we have to do now is to specify the stages that we want to use in this calculation, then 5 stages, and after to input the absences through the model modifiers. What can I do to specify the stages is simply to act via the load cases. Then what I can do here, I have a load case LC1. I can just do new. I do 5 because I need, in fact, 5 phases. And simply what I will do, I will rename them in order to be clearer. And I change here and I'd say stage 1, stage 2, stage 3, stage 4, and stage 5. Okay, and I remove this self weight here. Now let's go to create the absences. Where I found them? I found here in model modifiers. As you can see, the first things that you have to do is to create a modification group, because it's into the different modification group that you can input this absence. And after, you can associate the modification groups to the load cases. Then here I can go, and again I can call the modification groups in order to be clearer, like stage 1, and after I do new, stage 2, 3, 4, 5. Okay, close. And now I go in the part relative to modification group here, exactly where you have the load cases, and I switch to modification group. And now I can select in which modification group I place myself. Then let's say first a modification group, then the one associated to the stage 1. If we go back to the PDF, in stage 1 we have only the columns and this support here that I forgot to input. I will input just now. Then all the other things should be absent in this stage. Then let's go back to SCIA and let me just input the supports at the base of the columns because I forgot. Okay, and let's go back to stage 1, modification group stage 1. Okay, then I will put support absences. I will switch on the support in order to see them. No, not this one. Support absences, and then this support, this, and also this are absent. You can see there is a symbol that appears. I will change the visualization type, like this will be clearer. This symbol specifies that the support are absent in this modification group. And also, okay for this, but also element 1D absent, and it's this, this, and this. There is the yellow line to remind us that in modification group stage 1, everything highlighted in yellow and with the small symbol there, it's absent. Then let's move to stage 2. And again, let's go to see into the PowerPoint what we need. We need just to have this element, and all the other are absent, except also the column that of course are there. Then I go back to SCIA and I create exactly like before. Into the modification stage 2, I remove the elements that I need. Then I remove this and this. And for the support, remove this, 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 and this. Okay, that's done. Again, in the PowerPoint stage 3, there are the 3 beams and the support at the extremity. Okay, go back to SCIA. I put myself in stage 3 and I don't remove any element. The only things that I remove are the support at midspan of the beam at the extremity, then this and this. Okay, you can see the symbol appears. And after stage 4, let's see in the PowerPoint what there is. In stage 4, I remove the columns and I add this support here. Then let's go back to SCIA and stage 4, I remove the columns. Okay, and I remove the supports at the base of the columns. Okay, then in stage 4, There are the support at the extremity, the temporary support here, but there are not anymore the columns. And in stage 5, I remember what there is. In fact, there is just the 3 horizontal beam and the support at the extremity. Then I remove all the rest. Then in stage 5, I remove this column and this column, and I remove the support here, 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 and here. Okay. Uh, Also, in stage 5, my final stage, in my example, I also want to apply a load. Then let's say I move to load cases, and I'm going to add another load case just to add this load. I can call, let's say, stage 5 load. I can specify a load as I want, a permanent variable with all the coefficients and gone. It's not important. For simplicity, I just say permanent here, and I put myself into this stage 5 load, and I go to input a load. Then let's say a line load, 1 kilonewton per square meter, for meter, not square meter. Okay, and now the model is fully complete. I created everything. The only thing that is left is to associate the different modification group to the load cases. Then let's go in the load case manager, and let's start to stage 1. I associate the modification group stage 1 that I created. The same for the other. Then stage 2, I associate stage 2, 3 and 3, 4 and 4, 5, I put 5, and 5 load, I put 5 again. How can I do to put these two together? I can simply do or a classes or a combination. Then, for instance, I can go here in load, and I say a combination, and I can create, in order to visualize the result to the different stage in a simple way. Let's say I create a linear combination called phase 1. I put stage 1. Okay, and after I do new phase 2, and I put the stage 2. Okay, again another with stage 3, another one with stage 4, and another one, the last one, in which I put the two load cases, then the stage 5 and the stage 5 load, then the self-weight and the applied load. Okay, and to do something also more that I can do, I can create a class in which I put all this phase together, so that if I want, I can do the checks, the concrete check, metal check, or just to see the results, the internal effort, that are envelope for all the 5 stages. Then let's say I call this all phases, close. The model is done. Then the only thing I can do now is simply to run it. Before to run the model, just let me check that in the load cases I put the first stages as self-weight. Then that's fine. Yeah, that as I was suspecting, I forgot to switch on action load type self-weight, because if I don't do this, the self-weight of the element added or removed is not taken into account and will be empty. Then okay, everything is fine. Then let's compute, and let's go to see if the results are in agreement with the staged model that we want to build. Okay, it's computing. Of course, there are 5 stages. Okay. Then Before to go to see the results, let's go back to the PowerPoint. Then the first phase, we have again only the columns. The second, we add the horizontal element here. The third, we add all the horizontal part plus the external support. In the fourth, we remove the columns and we add the support here temporarily. And in the fifth stage, we remove this temporary support in red and we add a load. Okay, let's go to see. I switch off the visualization of the load and I move to a shaded representation. Let's go, for instance, to see internal forces. I put myself in, let's say, combination phase 1. You remember, I created several combinations, each one for each stage. Then if I put phase 1, and let's say I want to see bending moment, my, refresh, I don't see anything. That means the bending moment is zero everywhere. Why? Because these horizontal elements are not present in this phase. For this reason, nothing is shown. If, for instance, I go to show the normal force, and I click on refresh, I have normal force in the columns that are the only elements present in the stage 1. If I move to stage 2, what I should expect? I should expect that the normal effort in the column, it increases, because now it's not only due to the self-weight of themselves, but also the self-weight of this horizontal element should be taken into account. Then if I focus on this value and I click on refresh, you can see it increased because now there is also the effect of the presence of this element. And I can see this also if I visualize the my, because now I will have my in this element that is present. If I go on and I move to stage 3, to remember what there is in stage 3, what I should expect, you can see in stage 3 I have the horizontal part with the support at the extremity. Then if I click stage 3 and I select the my, you see I have the my associated. As you can see, I have not a discontinuity here because this support at mid-span of the extreme beam is not active in this stage. This support will become active in next stage, in which indeed I will remove the column. Then if I move phase 4, in phase 4 I remember again I remove the column and I add the support here at mid-span. You can see the discontinuity of the bending moment. It's this time here, and here there I have anything else because I have not anymore the columns. And I can see this, for instance, if I go to visualize the normal effort, I have no normal effort in the columns because the columns are not anymore there. And the same if I go to phase 5, then stage 5, all what I have in stage 5 is the whole horizontal part on the two extreme support and nothing else. Then if I click on refresh, normal effort I have nothing, but moment Y, I have my nice bending moment on the horizontal part. And you can see that really with simple ingredients you can create a staged model even if officially this functionality is not integrated. And again, all the other results that you can see in SCIA Engineer, they follow then these stages that you create. For instance, if I go on 3D deformation and I go to see the deformation associated to the combination to the stage 5, refresh, I have the deformation. Let's go with. If I go to see the phase 2, of course, not all the elements are there, but just this element, I will see the result associated. Now, there is something nice with this way to do than the use of absence instead than the use of the old solution of construction stages that is present in 32-bit version is that with absences, then with the 64-bit version, you can have access to all the checks in a staged model, something that was not possible with 32 bits. In 32-bit version construction stage function, you cannot do steel checks or reinforced concrete check on a staged model. In this way, you can, in fact, if, for example, I go, for instance, let's say I want to go to concrete, but I say that the menu is empty. Why this? Let me see here, empty again. I see it from the flag. In fact, the issue is that I'm using by hazard the old French national code, and the check are available for Eurocode. Then let's switch to Eurocode. Like this, everything will be fine. For instance, if I want, I can select French national annex of Eurocode. Okay, then now just I compute again. So to have access to the concrete checks that you can see in the bottom here, they appeared as I switched to the Eurocode. And so for example, if I want to go to reinforced concrete design, I can do it. Then I can say, okay, me for the stage, let's say 2, I'm interested to know the required reinforcement on this element. Then I switch on refresh, and it is working again, contrary to the old construction stage solution in which this functionality is not available. You see, in stage 2, I have only these 3 elements, then of course I have the result on this. If I go in stage 5 and I do the same, I have the checks, then the design on what there is in stage 5, then only the horizontal part. And here, for instance, I can take advantage of the classes that I created, the class in which they are all faced together. Like this, I can check the envelope of all the 5 stages, and so to design my element in a conservative way and to be sure that I took into account all the stages in the design of all the elements. Then if I do this, the 5 will be considered and I will have results for all the elements. Then probably this can be one reason if you do linear construction stage to use this approach instead to use the old 32-bit version, because again you have the big advantage that you have all the checks, and not only reinforced concrete but also steel, aluminum, timber and so on, that are available on a staged model. Okay, I think this was a bit what I wanted to show you today. Let's go to have a look to the question that you sent. Okay, one question that I got is which is the difference between linear and nonlinear construction stages? There are two differences. Of course, with nonlinear construction stages, as the word say, you can take into account nonlinearities in the model, but mostly nonlinear construction stages allow you to take into account the history of deformation on the structure. What I mean, I will show you with a simple sketch in Paint. Uh, let's say we are going to do the example that we just did. Then we have the two columns, the first stage, and after in the second stage, I add the element here. Then here we have the support. Do just a small sketch. Okay. Then this is our model at the stage 2, and now we are going to move to the stage 3. I do this a bit bigger. Okay. Then, okay. Then let's say here I have linear construction stage, and here I have non-linear construction stage. The difference is that at this state, the structure deforms under the self-weight. Then if I go, for instance, to draw roughly the deformation of the structure of this element, I exaggerate here, I will have something like this. Uh, uh, what is going to happen is that if I do the linear and the nonlinear process, when I go in phase 3 of this example, and then this was phase 2 and this phase 3. In the linear case, when I'm going to add the other element that here I represent in green, I don't take into account the history of the deformation. Then here, when I add the elements, they will be added like this, in fact, like in the initial configuration. In the nonlinear case, instead, I take into account the history of the formation. Then I know that when I go to apply the other elements, the elements don't see the previous element straight, but they see it here deformed. Then I will have, in fact, the choice how I want to put. If I want to put following the tangent here, then the drawing is exaggerated. But then if I want to follow the tangent or the initial position, but anyway, this initial deformation will be the starting point for the next stage. Instead, in linear construction stage, the starting point will be the structure as I drawing, then without the previous deformation. Then that is the main difference other than the fact that you can take into account other nonlinearity into the process. Then this effect can be big or small, it depends on a lot of cases. Many people just do linear construction stage, many people just do nonlinear construction stage, but yes, that it's the main difference between the two processes. However, I should say that if your intention is only to take into account nonlinearity of the model, like a beam nonlinearity, support nonlinearity, or I don't know, a surface element nonlinearity, but in general, any nonlinearity that is available as functionality, and then I show you here. And if you want to just use one of these nonlinearity, even the geometrical one, you can do it with the process that I showed you with the model modifiers. Because remember, the model modifiers are associated to the load cases, but the load cases, they can be associated to linear combination, but also to nonlinear combination. Then if you repeat exactly the same process I show you in the webinar with nonlinear combination, in which you really associate nonlinearity to the model, you will have absolutely no issue. And the calculation will run and without problems. But the only difference, then I repeat what I said before, is that the history of deformation will not be taken into account. Because in order to take into account the history of deformation, then the fact that when you add a new element in a new stage, this element will be added to the deformed shape of the previous stage. In order to do this, you need the full nonlinear construction stages as it will be implemented in the future version of SCIA. But again, if you only want to take into account nonlinearity in a simple way without to take into account the history of deformation, you can absolutely do it also now with the model modifiers. Okay, let's see if there is another question. Yes, it's about the example that I did. In fact, when I show the results of concrete for the classes, in fact, I didn't have results on all the elements. Let's go to check, and I do again. Result with respect to the class all stages, all phases, required concrete. Probably you don't see the results on this columns, it's just for a matter of scale, because if I switch extreme to member, then a numerical value for each member, and there is, in fact, it's a matter of scale with respect to the reinforcement required here. For this reason was not visible. Okay, let's see if there is another question. It's about absences, and it's yes. Currently, the question is, but absences now don't cover all possible cases. It's true because if I go in structure here, currently absences cover nodal support, 1D element, 2D elements, subregions, and after I have the stiffness modification. Then, in fact, you have not absences for surface support or linear support. But this again is something that is the situation now, but are elements that can be added if there is the request. The reason why they are not for the moment there is because there has not been enough requests by the part of the customers. But of course, if you want this function, just let us know via the official channel that is the support, then send the request to the support and they will transfer to the product team, and more requests we will have for some functionality, more will be the possibility to implement it. Yeah, okay. There are still some questions that I will reply later by mail because we are running off with the time. Okay, then I come back to the PowerPoint. Just to close the webinar, then I hope that you enjoyed what we saw today together. And again, I insist, if some of you is particularly interested in construction stage because you use it a lot, it's a functionality that it's very important for your job, please contact me. Then via support, then asking to contact me via the support, or just write your email asking to be called back, and we can take a rendezvous for a meeting in which we can discuss what you are expecting in construction stage for the 64 bits in the future, the functionality that you would like to have, what you didn't like so much in the old version you want to change, how to improve the workflow, and so on. Really, we are willing to hear from the user what they are expecting for construction stages module that is performing and easy to use for the user. Then really, if you want, don't hesitate to contact us. Okay, that's all from my side. Again, thank you for your participation to the webinar, and have a nice end of afternoon. Bye to everyone.